Hello dear math buddies! Welcome to my YouTube channel and thank you for watching my content wherein we are learning all about mathematics in an exciting and interesting way. By the way, my name is Sir Sherwin and I am ready to be your math instructor. And if you are new to my YouTube channel, make sure you help me and support me by subscribing to my YouTube channel and hitting the notification bell to be updated with my latest content. Please do follow and like my Facebook page and group, Math Sherwin MathTutorials, for more math lessons. For today's discussion, I will teach you on how to divide radicals. Are you ready to learn? With us, let's start this math lesson. Now! Alright, dear math buddies, welcome to my YouTube channel. Earlier, I mentioned that we will be learning on how to divide radicals. The question is, how will we do this? Before we divide radicals, dear math buddies, let us be equipped with this idea that in dividing radicals, we will divide it if we have common index. Again, they must have common index. And we can divide coefficient to its corresponding coefficient and radicand to its corresponding radicand. One more idea we need to remember, that a radical is considered to be simplified if there is no radical symbol in the denominator. Again, there will be no radical in the denominator. With this, are you ready? There are two ways on how to present division of radicals. We can have in terms of expression, wherein terms are separated by a division symbol. And the other is in terms of fraction. Both expressions are considered expressions that use division as our operation. With this, allow me to present our first example. Here, we have square root of 15 divided by square root of 5. Kindly bear into mind, dear math buddies, that in dividing radicals, we will simply divide this if we have common or same index. And we will simply divide radicand to its corresponding radicand and coefficient to its corresponding coefficient. From this certain expression, square root of 15 has an index of 2. Likewise, square root of 5 has an index of 2 as well. So, this means we can divide our radicals. And from this certain given, both terms have a coefficient of 1. So, we can directly divide our radicand. From this, we will have square root of 15 divided by square root of 5. That leads us to square root of 3. For the reason that 3 is the quotient when we divide 15 by 5. This means square root of 3 is our final answer. Let's have our second given. We have 4 square root of 21 all over 2 square root of 7. Again, both radicals have an index of 2. And 4 square root of 21 has a coefficient of 4, while 2 square root of 7 has a coefficient of 2. From this, bear again into our mind that we can divide coefficient to its corresponding coefficient. That leads us to 4 divided by 2, the quotient is 2. On the other hand, let us also divide our radicand, and we are referring to square root of 21 and square root of 7. So dividing 21 by 7, the quotient is 3. This means 3 will be placed inside our radical symbol, and our final answer will be 2 square root of 3. This is the simplified form of our second given. Let's try to have our third example. We have square root of 6 all over square root of 5. As what I mentioned earlier, this is one way on how to present division of radicals, and that is in terms of fraction. From this certain given, our radicals contain same index, and that is 2. But if we will look after our given radicand, 6 is divisible by 5. That leads us to a whole number. So how will we divide these radicals? The idea of rationalization will take place. When we are asked to define rationalization, we are referring to a process of eliminating radical symbol in the denominator. So with this, let's try to apply rationalization in simplifying these radicals. In rationalizing, one best suggestion that I can recommend is to multiply our given expression, both the numerator and the denominator, by square root of 5. Why square root of 5? In order for us to make this one a perfect square and for us to eliminate radical symbol. So let's try to rationalize. So by multiplying both numerator and denominator by square root of 5, this leads us to square root of 6 times square root of 5. Radicand, multiply to our radicand. So again, 6 times 5, that leads us to a radicand of 30. While our denominator will be square root of 5 times square root of 5. That leads us to square root of 25, or in exponential form, that is 5 squared. Here, we noticed that our index and exponent of the radicand is the same. It follows that we can eliminate our radical symbol. So it leads us to square root of 30 all over 5. So square root of 30 doesn't have a factor where 1 is a perfect square and a non-perfect square. So we can consider this as our final answer. So square root of 30 all over 5. Let's have the fourth one. So again, we can simply divide our radicals if we have the same index. So here, both radicals share the same index, and that is 2. But then again, we have the similar radicals because we contain different radicands. And our dividend cannot be divided by our divisor. That leads us to a whole number. Again, the process of rationalization will take place. We can rationalize our given expression by multiplying both the numerator and the denominator by square root of 3 to make this denominator a perfect square. So we will multiply both the numerator and denominator by square root of 3. From this certain expression, for us to simplify our numerator, we will apply distributive property as we multiply square root of 2 plus square root of 7 by square root of 3. So again, by distributive property, so square root of 2 times square root of 3, the product is square root of 6. While square root of 7 times square root of 3, the product is square root of 21. And in our denominator, multiplying square root of 3 and square root of 3, that leads us to square root of 9, or an exponential form, that is square root of 3 squared. And our index here and denominator is the same, so we can cancel this out. And it leads us to square root of 6 plus square root of 21 all over 3. Here, we don't have a radical symbol in the denominator. And likewise, our numerator contains the similar radicals. In our previous lesson, we can only add radicals if they are similar radicals. So, we cannot combine or add these two radicals. Therefore, our final answer for number 4 example is square root of 6 plus square root of 21 all over 2. In my next content, I'll be providing more examples on how to divide radicals. Feel free to send me your messages via Facebook page, Sherwin Math Tutorial, if you have questions, if you have clarifications, or inquiry with respect to my discussion for today's video tutorial. Likewise, you can send your mathematical expression in division of radicals for me to help you. There you have it. Hope you learned something new today. God bless us all.